Hello, thanks for watching this video and studying your math with me. 2 points are worth keeping in mind. One thing is this video is not a substitute for reading your book, so please work to do that. And the second thing is you can use the YouTube commands to rewind, play, pause, or forward this video, and that can help you to test and or ensure your understanding. We're going to go through several examples. This first example asks us to identify each set as finite or infinite and then determine whether 8 is an element of the set. So we see that 8 is in this first set, and 8 is also in the set called D. And it's the only element in this set called D. There are other elements in both A and D are finite. The other sets are infinite, and in neither one of those is 8 in the set. The next example asks us to list the elements of the set. So here we have the set of x such that x is a natural number between 8 and 12. That is only set containing 9, 10, and 11, listing it in the roster method. And down here, the only natural number greater than 6 and less than 8 is the number 7. Example 3 asks us to discuss subset relationships between a universal set given by this one, sets A, B, C, and D, and determine whether each statement is true or false. If I asked you such a question, I would also ask you to justify your answer. So here we find that B is not a subset of D because there's an element in B that's not in D. Here we find that D is not a subset of A because every element in D is in fact in A. So D is a subset of A. In fact, D is what we call a proper subset of A. So both of those are false. Both of these are true. D is a subset of B because you can see that every element in D is also in B, and A does not equal the universal set, but A is contained in the universal set, but there's an element, namely 39, in the universal set that's not in A, so A is actually a proper subset. Here's some fill in the blanks for set operations. I think I'll just let you read these. It defines the complement of a set, all elements that are in the universal set not in set A. The intersection of set A's is a set of elements that are in A and B simultaneously, and the union of set A's and B's, written this way, is made up of all elements belonging to set A or set B, or even both set A and B. That's an inclusive or. This example asks us to find the complements of various sets, denoted again by the prime. And we find these are the answers. Note that the complement of the universal set is what we call the null set or empty set, and the complement of the null set is in fact the universal set. Here we're finding the intersection of these two sets and identifying any sets that are disjoint, meaning they have. And so here we find that the only set, element of the set in both of those sets is 30, so that is the intersection. Here 6, 12, and 18 are in both, and here these are disjoint sets because this is 3 distinct elements, and that is one element, namely the number 678, so those are disjoint sets. Here we're finding the union of 2 sets, so we find what is in each set, put them together, including the things that are in both sets. Notice that we only have to list each set element once. To close, remember, time is precious. Each day must count. Doing the math will make you strong. See you in class.